Hi 8th grade, this is Miss B here with lesson 4.9. Let's begin by going over our do now. So last week we learned how to solve systems of equations graphically, in which we graph the first equation and the second equation to find the point of intersection. So the first thing we need to do is check that both of our equations are in slope-intercept form, or y equals mx plus b form, so that we can use our y-intercept to begin and our slope to move. So our first equation, we have a slope of 1, since the coefficient for x is 1, and we have a y-intercept of positive 2. In our second equation, it's in standard form, so we can't yet identify what m and b are. So take a moment to put this equation in y equals mx plus b form. We need to bring the 2x to the right-hand side of the equation in order to have it in slope-intercept form. So when we subtract 2x on both sides, it cancels out on the left, turns to 0, and we're going to bring down what we have left, which is the y. We cannot combine 8 minus 2x since they are not like terms, so we're going to write them next to each other, and the term with the x comes first. The reason why that is because in slope-intercept form, the term with x is written first. So we're going to write it in that same order. So now we have a slope of negative 2 and a y-intercept of positive 8. So take a moment to graph both of these lines if you have not done so already, and unpause this video for the solution. So as we can see, the point of intersection of these two lines is at 2, 4. Remember to write your final answer as an ordered pair and to label each line with its respective equation. In today's lesson, we're going to be solving a system of equations algebraically. We're going to use the same equation or the same two equations from our do now as part of our mini lesson for today. So let's recall the solution from our do now, which was the point 2, 4. So our solution was 2, 4. Just making a note of that now, because what we're going to do is a different way to solve for the same exact solution. Instead of graphing it on the coordinate plane, we're going to solve for it algebraically. So to solve a system of equations using substitution, we're going to solve one of the equations for y. So that's the first step that you're checking for. So let's go through each step as we go through the example. So in number 1, as you can see, the first equation, y equals x plus 2, is solved for y. We have the y by itself on the left-hand side of the equation. So we actually have step 1 done. Step 2 is to substitute your result into the second equation for y. So since y is equal to x plus 2, we're going to take x plus 2 and replace it with the y in the second equation. When we're replacing it, what we're doing is using substitution. So let me write it out so it's a little bit bigger. So again, what we're going to do is take x plus 2, which is what y is equal to, and substitute it for the y in the second equation. So we're going to replace y with x plus 2. And we're going to get something that looks like this. So what I've done right now is put parentheses where y is in the second equation so that I can write what it was equal to in my first equation, which is x plus 2. So now we've got a multi-step equation, and our job is to solve for x, to get that first variable by itself so that we have the x coordinate. So follow along while I guide you through the steps on how to solve this equation for x. So the first thing we need to do is make sure that we don't have any negatives or any numbers to distribute where our parentheses are. Remember, if you do not have a coefficient, the coefficient there is always 1. So since we're distributing a 1 into these parentheses, we're really just taking them out of the parentheses. So we have 2x plus x plus 2 is equal to 8. So now before we add and subtract or use inverse operations, we're going to simplify by combining like terms on each side of the equal sign. So 2x plus x gives me 3x plus 2 as our constant. We don't have any other constants on the left-hand side, equals 8. So I'm going to start by looking at my variables. I have x on the left-hand side, and I don't have any x's on the right. So I know that I have to bring my constant to the opposite side by subtracting 2. So we're left with 3x is equal to 6. And now when we do the inverse of multiplication, sorry, I don't really have much space to write there, we get 6 divided by 3, which tells us that x is equal to 2. So we found the x coordinate of our solution to the system. And look at what we had for x when we solved it graphically. We have a value of 2. In order to solve for y, which is 4, it's what we had when we graphed it, we need to substitute the x value that we just solved into either one of these equations. We're either going to substitute it into the first one or into the second one. It doesn't matter which one you choose, it'll give you the same value for y, but one of these is easier to substitute. Since we're solving for y, we're going to plug it into the first one. So we have y equals, now instead of writing down x, I'm going to write down what it's actually worth, which is 2, and we are adding 2 to it in our equation. So what does 2 plus 2 give us? 2 plus 2 gives us a y value of 4. So there you have it. We have a solution at the point 2, 4, which again is exactly what we found when we graphed these two lines. Okay, I know I didn't do a very good job with referencing these steps that we're using here, but I'll be sure to do that in this example. So again, step 1, solve one of the equations for y. Our second equation is already solved for y, so the first step is already done for us. Substitute your result into the second equation and solve for, well, it should say the other variable. So we're going to take negative 4x plus 24 and substitute it for y in the first equation. So we have 2x minus 3 times negative 4x plus 24 is equal to negative 2. So now we're going to solve our equation for x. In order to combine like terms, we need to eliminate the parentheses that we have here, and the way that we're going to do that is by applying the distributive property. Now we can't do anything with the 2x just yet, since we have to subtract that from what we simplify from our parentheses. So we have negative 3 times negative 4, which is positive 12x, and negative 3 times positive 24 gives us negative 72. And that's all equal to negative 2. So now that I've distributed and gotten rid of those parentheses, I can start combining like terms on the left-hand side. 2x and 12x gives us a 14x minus 72, since we can't combine that with anything on the left, equals negative 2. In order to divide by 14 as our last step, we need to bring this constant to the opposite side of the equal sign by using inverse operations. So negative 72 plus 72 gives us 0. We have 14x on the left equals negative 2 plus 72, or negative 72 minus 2 gives us a positive 70. And finally, if 14 times x equals 70, the inverse of multiplication is division. If we divide by 14 on both sides, we find that x is equal to 14. That's not right. Okay, I don't know what I was thinking there, but 14 times 5 gives us 70. So if we divide by 14 on both sides, we find that x is in fact equal to 5. So we found the x coordinate to the solution for a system. So we've gone through the first 3 steps, and now we're at 4. We're going to use x to determine the value of y. So we're going to substitute this into one of these 2 equations to solve for the y value. So I'm going to substitute it into the second equation, since that one is already set equal to y, and looking at the first one, I would have fewer steps in solving for it. So we have y equals -4 times 5 plus 24. Y equals -4 times 5 is -20 plus 24. -20 plus 24 gives us a positive 4. So the y value of our coordinate is going to be 4. And finally, step 5, express your solution as an ordered pair, as xy. Now this is where you would lose a point for just getting lazy and not writing your final answer the way that it's supposed to be written. Remember, a solution to a system is where the 2 lines are going to intersect on a graph. So since we're solving it algebraically, we need to put the x and the y together as an ordered pair. So the solution is going to be at 5, 4. And there you have it. Now it's your turn to practice solving a system of equations using substitution. You're going to have an hour to work through problems number 3 through 11 for full classwork credit. Whatever is not done in class is to be completed for homework. So your homework for tonight is really just problems 12 through 17. It's 6 problems. If you get it out of the way in class, you have less work to do after school. Have a great day, and make sure you ask questions and ask for help if you get stuck.